I heard when I was out, you guys went through and you did this front page. It looked like yours might have ended up looking similar or maybe a little different the way you took the notes. But this was the perfect review for the test. It'll probably be coming up either Friday or Monday. I will let you know. Actually, it might end up being Tuesday. I bet it's gonna be Tuesday. No, your test will be Monday. Okay, decision's been made. The test will be Monday. I'm gonna be out on Monday. Oh, so the test will be Monday. And this is we have 2 more things to learn before we take the test. This was a really good review. It just so happened it was a perfect break, or you had that break. This is a perfect place to come back and review. You absolutely need to know that weathering is the breaking of rocks. You need to know the difference between chemical and physical weathering. I do think the most important part of this review was this set of questions here, which said name the 5 agents of erosion and list 1 landscape feature created by each. I ended up making a list of more than just 1. But these are the things you've got to know. You got to be able to say, okay, here a glacier made U-shaped valleys or moraines or kettle lakes. And you saw that pop up in the questions that you followed up with this afterwards. So speaking of the questions, that's where I want to start right now. You guys didn't do those together, right?
We did.
Okay. So let's start with question 1. It says, which event is the best example of erosion? Quick review. What's erosion? Moving. So it's really asking which one of these is an example of moving sediment. So which one did you say? A, B, C, or D? Show me on your fingers, please. Just do it. Don't look at anybody else. Just throw them up. 1, 2, 3, or 4. Everybody's throwing up 2, it looks like. And that is true because rolling of a pebble along the bottom of the stream, that is an example of the pebble being moved. Quick review. Answer A, dissolving of rock particles on limestone gravestone by acid rain. What is that an example of? Which is, keep going. Chemical weathering. This is chemical weathering. Does anybody remember the fancy name for acid rain weathering? Carbonation. Good. How about answer C, breaking of shale as a result of water freezing in a crack? No, it's not it. What is it? That is weathering again. That is what kind of weathering? Water freezing in a crack. Frost action. Root action is, oh, never mind. It's not the next one. I thought it was. Crumbling of bedrock. Again, that's an example of weathering, breaking the rock. All right, this block diagram below shows the displacement of rock layers. What do you see in this picture?
A cliff.
A what?
Cliff.
A cliff. And what do you see at the bottom of the cliff? What's right here at the bottom of the cliff? Right there.
Lake.
There is a lake. There's also a pile of sediments here. And then you can see the arrow moving the rocks this way. Without looking at the answers, what kind of erosion would you have called that? Where stuff falls down a cliff? Don't look at the answers. Tell me of the 5 agents of erosion we talked about. Gravity. Is gravity one of the answers?
No.
No.
It's not. One thing I'm not sure if this class ever talked about or not was the term mass movement. Did we ever talk about mass movement?
No.
All right, grab your packet. Everybody grab your packets, open them up to page 8, please. On page 8, we took note. We did big ideas for glaciers, wind, gravity. We drew some pictures for each. But one thing I think I forgot to do with you guys is tell you another name. You're shaking your head. Did I do this or did I not do this? I did? Okay, we'll see. Right here, gravity. If you don't already have this, I'd like you to do / mass movement. So did you guys have that already? Okay, so we did talk about it then. Right, we'll get them for you, don't worry about it. Okay, since we're right near the end of the chapter, I'm not worried about you getting the stuff you've missed so far. But knowing that mass movement is another name for gravity is really important for you guys. So just like always, you technically don't need to use the fancy word. So on the front page of this, when I asked, name the 5 agents of erosion, and you listed gravity, that was perfect. But you do need to know what the fancy names mean. So in this case, they didn't say gravity erosion. They said mass movement erosion. So you do need to recognize that mass movement is the same thing as gravity. And gravity is what pulls rocks down a cliff in this example. So the answer to number 2 is mass movement, which is gravity erosion. How about number 3? Which agent of erosion is mainly responsible for the formation of depressions that occupy both the Kettle Lakes and Finger Lakes found in New York? Those are those key words you need to know. Kettle Lakes, Great Lakes, Finger Lakes. What makes those? Glaciers. So that's what I keep meaning. Or when I say you don't need to really know what they mean, you just need to know what makes them. So I want you, when you hear Kettle Lakes, Finger Lakes, Great Lakes, striations, moraines, U-shaped valleys, I want bells and whistles going off in your head saying, woohoo, woohoo, glaciers made those. So glaciers make Kettle Lakes and Finger Lakes. How about this? The photograph below shows a sand dune in a coastal area. They tried to trick you there. What makes a sand dune? Wind. So looking at the answer, the sand dune was most likely formed by wind blowing, water flowing, or water flowing. Wind blowing. I can get rid of the water flowing answer. Now, is the wind blowing from the left or right in this picture? How do you know? Not the wind on the steep side, wind on the gentle side. So the wind is over here. Wind on gentle side. And so that's the right. And lastly, what is the most probable arrangements for rocks dropped off by glaciers? What do we know about glaciers? Layered or sorted or unsorted? Glaciers are unsorted, so we get rid of the 2 sorted. Are they unsorted and layered or unsorted and not layered? Not layered, because remember, layering is a type of sorting. If glaciers arranged them in layers, they'd be sorting them into layers. So that's not correct. Which one of these will settle to the bottom of a stream fastest? So what is it? Let me actually read it. So it's which particle will most likely settle to the bottom first? What'd you pick? Settling to the bottom first. Holy cow, guys, participate. Destiny, you answered this. Thank you. You picked which one? I couldn't hear you. You picked A. So X will settle to the bottom first. What else did we pick? W. Did anybody else pick any other letters? Did you pick Z? Why not Z? And what happens with flat? They settle to the bottom like this. So this one's going to be really slow. What's the difference between these 2? They both look the same size. Density, and which one settles to the bottom faster? Higher density or lower density? Higher density. What about W or X? They have the same density. X is smaller. So which one hits the bottom first? The bigger one or the smaller one? Bigger one. It is going to be W. So what are the 3 things that affect settling rate? So when they, how do they get to the bottom faster? What do they got to be?
They gotta be bigger.
Big,
Round.
round, and higher density. So guys, I just wrote this note here. If you're ever going to look back at this packet when you're reviewing how to do this stuff, that might be a good note to have on the side of your paper. Okay. Explain why acid rain can weather limestone bedrock.
Acid rain reacts with the calcium.
Okay, what calcite? Okay, so guys, I would be careful with this question. Now, I've said before, you do not have to use complete sentences, but I need a complete thought. So you just said calcite reacts with acid, but you gotta tell me a little bit more. So what if calcite reacts? You didn't tell me anything about calcite. So I would just keep going and say limestone is made of calcite. And then you can continue on to say calcite reacts with acid. So again, I mean, it doesn't have to be a beautiful ELA essay sentence, but you need and if you do a beautiful essay sentence, more power to you. But you do need to make sure you at least have a complete thought. Limestone is made of calcite. Calcite reacts with acid. Question 8, complete this for 3 agents of erosion, identifying one characteristic surface feature. So again, it has to be something that's going to show up on the surface after that agent of erosion has gone through. Now, I only asked for 3, but there are 5. And basically the answers to this question are right here. So which one it makes a U-shaped valley, Zach? So one example could be a glacier, and it makes a U-shaped valley. You could have also included in that box, could have said glaciers make moraines, or striations, or outwash plains, or Finger Lakes, or Great Lakes. Any of those are good. Give me another one, somebody else. Kat, what did you pick for one of them? Okay, so you could have said, so running water is perfect. You could have also said streams or rivers here. Okay, so you went with delta, Zach, what'd you go? And what's that called? Okay, so that's a delta. So add that to your answer, okay? So I am not sure, and that was actually going to be one of my examples, is I'm not sure if sorted sediments is good enough. I think it would be good, but it does say surface feature. So they want, I think, a name of something, but I personally would have accepted sorted sediments. So just be careful with that one. So you could have also included V-shaped valley, not moraines, V-shaped valleys, meanders, or the deltas are good. Carter, what was your third one, or what else I have glaciers and running water so far? Gravity, what'd you use as an example?
Mudslide.
A mudslide would work, avalanche, called a talus slope, any of that would be best. Good. Anybody got another one that I didn't already have? Yep, Felicia. Wind, and what was your example? Yep, most people would have done sand dune. You could have also done desert pavement or arches, mushroom rocks. And what's the 5th one that we don't have? What am I missing? Waves. And what are some examples of surface features from waves? Sandbars. Sandbars, beaches, sand spit, barrier islands, any of those would be good. Anybody have something there that they're not sure would be accepted?
No.
I have seen this type of question pop up a lot. And with this, if this was a Regents, you would have had to have all 6 of these boxes correct to get full credit. It would only be worth 1 point, and you had to have 6 boxes filled in correctly. What's going on here with this picture where it went from jagged and large to round and small? That's weathering. FYI, what type of weathering is this? Where it goes from jagged and large to round and small. It is physical. What kind of physical weathering? Abrasion. That is another thing I'm gonna tell you, you need to know, is that we go from large and jagged rocks to small and round. That's abrasion. Next page, almost done here. Oh, we've got an arch that formed in the western United States. How did this arch most likely form? Yes, the bedrock of the arch was more resistant to weathering. It was putting up the biggest fight. All right, what type of climate has the greatest frost action? So first of all, do we need dry or wet climate? Wet. I get rid of the two dry. So then we have wet climate in which temperature remains below freezing, or wet climate in which temperature alternates from below to above freezing. We have to have that alternating. It has to melt, then refreeze in a crack, make the crack bigger, then melt again, get more water, freeze again. All right, we want chemical weathering, best climate. Warm and moist, answer C. What occurs when a rock is crushed into a pile of fragments? Let's read part of the answers. Total surface area increase or total surface area decreases? Increases. When we break a rock, it makes more surface area. So will that surface area so since it increases, does chemical composition change or remain the same? We're just breaking it into pieces. The chemical composition does not change. It remains the same. Answer B. Did you?
Yeah.
This next question, I think if you did not read it, you might be confused. So it says the diagram below represents represent particles of the same type of sedimentary rock material collected from a stream bed. The rocks are drawn to actual size. Equal masses of the three types were placed in containers of weak acid and shaken. Which particle size will weather the most rapidly? So we have particle A. Then we have particle B, but remember the direction said they had equal masses of each. So what that's really saying is we had a pile of B-sized rocks, but their mass was the same as A. Then the same with C. It says we have a pile of C, well, that's got too big. A pile of C-sized rocks. But you add up their total mass and it still equaled A and B. So that was the key, is we had the same mass of each rock. Now, which one's going to weather faster? One big rock, a bunch of medium-sized rocks, or a whole bunch of C-sized rocks? Which one has a faster, will weather most rapidly? Think of this as a sucker. You have a whole sucker, you have a sucker crushed up into a few pieces, or a sucker crushed up to a bunch of teeny tiny pieces. Which one will dissolve faster? The tiny pieces. Here's my question though. Why? There's more what? There's the same mass of them. More surface area. When you break, that's why I put that last question first there. When you break a rock, you increase surface area. So that means there's more places for the acid to touch that rock. Okay, so no need to guess. Which evidence suggests the landscape feature has been eroded by a glacier? What does a glacier do here? What do you think, guys? Glacier. C, parallel grooves. Grooves are big scratches. All right, best evidence of erosion. What does erosion mean again? Moving. Which one proves rocks have moved? A, sediments observed at the bottom of a cliff. Which one of these is transported greatest distance by a stream? Jagged or round in a stream? Rounded, so not A, not D. Will its volume decrease or its mass increase as it's traveled along in a stream? What does volume mean, by the way? It's the amount of space it takes up. So it's really just saying its size. So will its size decrease or its mass increase? B, the size will decrease. And lastly, which one of these was left behind by a glacier? Why A? Unstorted. Geniuses. All right, so what we're going to do now is I need everybody to grab your reference table. It has been a hot minute since we have used our reference table. Did we? I think we might have glanced at them, but we're gonna full blown use it now. Page 6. Do you need a folder or a binder? Which do you like better?
What page did you say?
We have. Maybe a different one, this one too. This one's definitely being better. It's used, but. There you go. All right. Come on, please, Carter. Anyways, we are going to go to page 6 of our reference table. And as Zach was so pleasant to point out, or so nice to point out, we've used it all before. We just haven't gone into detail about this reference table. The one in the upper, what is that, right-hand corner? We've used it before. We used it when I asked, well, how big is a pebble? How big is a cobble? And that was easy enough to use because it had these dotted lines. So a boulder is anything bigger than 25.6 centimeters. A cobble between 6.4 and 25.6 centimeters. Same with pebbles, they're between 0.2 and 6.4 centimeters. We've done that before. That should not be new. But the rest of the graph should be pretty new. So let's start with the title. Relationship of transported particle size to water velocity. Guys, what's water velocity? The speed of the water. Now, normally we do speed in miles per hour. This one is in centimeters per second. So remember how big a centimeter is? A centimeter is about how fat your pinky is. We're doing centimeters per second, not miles per hour. So we got velocity in centimeters per second on the x-axis and particle diameter in centimeters on the y. Keep in mind over here, they did tell you how big the certain particles are. So there's a lot going on this graph, but other than that, it's just a graph. Now, I have a question. I would like you to look at that graph and see what's wrong with that graph. Like if you were to make this graph, what about this graph is wrong? There's something, there's actually something. So let me ask this again. What's wrong with this graph? If I said make a graph, what's wrong with this graph? What are some of the rules for graphs? Do you see something wrong, Keith? It does not go up at a constant rate. What Keith is saying is normally when you do a graph, you have to pick what you go up by, whether you go up by ones or fives or tens or hundreds. Here they did no such thing. Take a look here. I want to start with 1 centimeter per second. Everybody find 1 centimeter per second. What is it counting by when you go from this 1 to the 10? What are those counting by? They're counting by ones. 1 is here labeled, which would make this 2, 3, 4, 5 is labeled, 6, 7, 8, 9, 10. Perfect. What's the next section counting? So where it goes from 10 to 100, are they still going up by 1? Now they're going up by 10. How about the next set of box? The numbers in the next box. Now they're going up by 100. That's one thing that's wrong. They're not going up by nice even numbers. Do you also, while you were counting those, did you notice the other thing that was wrong? What about spacing on normal graphs? What do you have to do when you space?
Equal.
They normally have to be equal. Clearly, these are not equal. The 10 here that I'm pointing to, and then over to the 20 is a fairly decent gap. But if you look after 50, they're all squished together there. This graph is not wrong. It's just an exponential graph, and I think they threw it on there just to mess with your head. They could have done it otherwise, a different way that would have been much easier, but making things difficult is part of their job, I think. So it's not super hard. You guys caught on real quick. This first section counted by 1. Then we bopped over to 10s. And then we started counting by hundreds. What do you think right here is counting by? Where it starts with 0.01. Did you catch the trend? It's counting by 0.01. So 0.01, 0.02, 0.03, 0.04, 0.05. What do you think this section starting with, or that starts with 0.1? What do you think they're counting by? They're counting by 0.1. So they give you a hint to what they count by what that 1 was labeled by. This group counts by 0.01. This one counts by 0.1. This one counts by 1. Same with the y-axis. They go up. Here's 0.00001. This is 0.0002. So they count by whatever that first label was. Other than that, this is not overly complicated. It's just telling you how fast the stream has to move to carry different sized rocks. I forgot to hand these packets out. Nope, not those ones. I hopefully picked them up. No. I guess kind of a chance to do your homework. Yeah, you have homework. Yeah, I forgot to write it. I'll write it. No worries.
Oh, it's not there.
They're gonna have double homework tomorrow. I would like you guys to grab this that we just handed out. What is the smallest and largest diameter for each of the following? We're gonna skip that one for now. Let's go to question 2. What is the largest size particle a stream can carry flowing at 200 centimeters per second? So we want to know the largest size a stream can carry that's going 200 centimeters per second. What do we do? 200 centimeters per second. Where is that on this graph? X or Y? X. That's the first thing, because some of these numbers are very similar. So always double check, what did they give you? They gave you 200 centimeters per second. What the heck? Where's 200 centimeters per second? Good. That's a perfect description. It's the first little line after 100. Now, I still had my Post-it note stuck to my paper here when we did rocks and minerals. It looks like most of you don't, but a straight edge might help you with this. Notice how there's marks on both the top and the bottom of this graph. There's a nice perfectly straight line. If you don't have a perfectly straight line, you might get a very different answer if your line is crooked. So I can pass out more Post-it notes if you'd like, but there's 200 centimeters per second. What is the largest size particle that 200 centimeters per second can carry? How do I figure this out? Go to 200. What do I do now? Go up till you hit that black line. And go over. What do you think? So I heard about 9. Here's the 10 line. Are we really lower than 10? I don't think so. Okay, not 11, because what is that next line up? 20. I'd say around 20. You could say 20 centimeters. And then what kind of sediment is 20 centimeters? So finish that for homework. So is 20 centimeters, is that clay, silt, sand, pebbles, cobbles, or a boulder? That's a cobble. So I would like you to put both of those there. So your homework is this whole first page of this packet. Not the second one, not the multiple choice, just the entire first one, even question number 1 that I had you skip at the beginning. Everybody understand what your homework is? Just this page. Got it? Remember, we do have that benchmark coming up. So the benchmark starts in lab for my lab students. We're starting that tomorrow. I believe Mr. Miga's waiting till Friday, I think. No. He's only giving 1 day for it, that's why.